Hello dear users of digital photogrammetric workstation PHOTOMOD. Today we will talk about creation and preliminary processing of UAV data projects. In contrast to a classic aerial survey done with big size planes, UAV survey is specified by flight instability, different angles and different survey heights for adjacent images. If UAV is not equipped by precise dual frequency GPS, an accuracy of telemeter data can achieve 100 meters for projection centers and about from 7 to 20 degrees for yaw pitch roll angles. It complicates automatic forming of block layouts and leads to a big number of rough residuals while searching type points. It should be noted that there is no general workflow for processing of UAV data in PHOTOMOD. Step-by-step technique which is effective for one type of UAV may be not relevant for other type of UAV. In frame of video tutorial we will talk just about recommended sequence of actions and important issues regarding processing of UAV data. First of all, it's necessary to check source data. To get a good result we should have images, interior and exterior orientation data, as well as ground control points and their sketches. Exterior orientation data and GCPs should be supplied along with information about coordinate system, height system and a priori accuracies of measurements. Apart from standard PHOTOMOD, there is a special product PHOTOMOD UAS, directed to processing of UAS data. While supporting the similar functionality, it has more simplified interface. The one limit of PHOTOMOD UAS is the size of image loaded. It mustn't be over 60 megapixels. Let's start PHOTOMOD UAS. And create new project. UAV project, central projection is the type of it. Coordinate system WJS84 UTM zone 37 in the northern hemisphere. Relief elevation is between 120 and 260 meters. Select a placement for storing the project in PHOTOMOD resource system, how to create a system of profiles and resources. Please watch corresponding video tutorial. Okay, let's create new strip and images from files. Firstly, raw images should be converted to internal PHOTOMOD format MSTIF. We don't recommend to create images folder in projects folder directly, since accidental deleting of project can lead to removal of images as well. In the left column, select a folder with raw images, add them to the list. Let's leave conversion parameters as is, specify folder for storing converted rasters and press convert button. All options of this window was considered in detail in video tutorial dedicated to processing of aerial survey project. If necessary, when we deal with a big number of images, a conversion can be done in distributed processing mode while using all cores of PC or all machines in local network. If we need to add images while using distributed processing option, we should preliminary open distributed processing control center and perform the same operations from raster converted window. So the one difference of raster converter window from the window of adding images from the files is an absence of distributed processing button. So let's look at all images and then import interior and exterior orientation parameters from metadata. Orientation, import orientation from metadata. Let's open Manage Cameras window and check that orientation of camera axis is really 270 degrees clockwise. X-axis should correspond to flight direction. While moving from image to image, be sure that it's really oriented in a such way. Everything is alright. Let's look at camera parameters. This is Sony NEX camera. This is no professional, no calibrated camera. Its interior orientation parameters is specified not accurately enough. We will back to it soon. Let's close cameras window and open window with exterior orientation data list. As we see, just time of taking every image have been imported from metadata. That's why we should import projection centers, we should import angles manually. Now please form a right structure of exterior orientation parameters list dependently on your data. In my case, import mode is latitude, longitude, field separator is top, decimal separator is point. If necessary, replace the name of columns in default if necessary, but in our case pitch and roll values are not accurate. That's why I change it to star symbols. You may find that value of angle, for example, for the second image from the list is rather big, about 61 degrees. It indicates us that this angle is not accurate. Next. UAV was equipped by single frequency GPS. That's why a priori accuracy of projection centers is not good, about 10 meters. leave accuracies of angles as is in default. Execute, apply, and now block scheme is rebuilding automatically. Then we need to split block into strips based on exterior orientation data. Block split into strips by exterior orientation data. Okay. Now we have 3 strips of images instead of 1 strip that was loaded before. Visual check of block layout shows as accurate exterior orientation data is. If images are laid in a random manner, it's necessary to perform the additional correction. Automatic UAS triangulation. To get the best result of correction, let's move slider of performance and precision to max. If performance slider is specified in speed mode, UAS triangulation will complete faster, but type points will be measured just between pair of images, not in triplets. Be sure that distributed processing control center have been started. Okay, and press distributed processing button. Since I have 4 cores, since I have 8 cores in PC, in my case, and I have 44 stereo pairs in the project, specify 6 stereo pair per task. Select default folder for storing results and press OK. Check that after run button is pressed in monitor of distributed processing. It's OK. Okay, after performing UAS triangulation, a block layout is rebuilt automatically in mode by centers. If necessary, let's open report on relative orientation. And be sure that the most part of stereo pairs and triplets have been created. At the moment, don't pay attention to residuals values. Now my task is to make these dice more accurate and delete points with rough errors. Open automatic type point measurement window. Activate preset UAS and use all its settings in default. These settings are specified by experiments at the first approximation for our photogrammatical processing. Press distributed processing. Task number is in 2 times more than course number. Since apart from points measurement tasks, include points transferring. Okay. Okay, after completing, open report on relative orientation once again. Specify thresholds, 2 pixels for vertical parallax, 3 pixels for triplet residuals in XY plane, and 8 pixels for triplet residuals in Z. Okay. All measurements meet to specified thresholds. Now it's time to load into the project list of ground control points. If necessary, specify titles of unnamed columns. In my case, columns with a priori accuracies of GCP's measurements. Deviation for X, standard deviation for Y, standard deviation for Z. Stat import from the second column. Okay. Now it's time to identify GCPs in images. Double click on the first point from the list. Find its accurate position in the first image. And press Insert key from the keyboard. Make this image as left. And press button Correlate all images to left. Okay, the first GCP OP04, is measured in 2 images. All the other GCPs should be measured in a similar way. To save time, I just load preliminary prepared file with measurements of other GCPs. Apply, OK. And rebuild block, taking into account GCPs. Now let's step to a block adjustment. All the options associated with adjustment were described in detail in video tutorial dedicated to aerial project processing. On the bookmark adjustment, use a block scheme as an approximation method without using exterior orientation angles, and without direct georeferencing. This method, option by block scheme, is recommended to use in default since very often UAS server is organized with gaps instead of triplets. Bundle adjustment is used as adjustment method. In adjustment parameters, please deactivate using exterior orientation angles as well. Specify acceptable residuals on the bookmark report, depending on a scale and type of output product. For creation of 1000 scale typographic map in accordance with photogrammetrical Russian instruction, acceptable residuals looks like this: 20 centimeters for XY plane and 33 centimeters for Z. Theoretically, it's possible to achieve better accuracy. If to consider that adjustment accuracy on GCPs in XY plane seems to be equal 1 pixel or 6 centimeters in our case, since GSD of images loaded is 6 centimeters. Adjustment accuracy in Z will be theoretically equal 1 pixel multiplied by ratio of camera focal length and survey basis in image scale. About how to measure it, please watch a video tutorial dedicated to adjustment of aerial project processing. In our case, theoretically it's possible to achieve adjustment 3.5 pixel or 20 centimeters accuracy in Z. Okay. We have specified parameters of adjustment. Press compute. Open a filter to display just type points or acceptable residuals on image. Or acceptable residuals. Just type points. If necessary, I may hide visibility of block scheme and raster. Keeping shift button of the keyboard, I select all type points. There is over acceptable residuals and specify them as excluded. These points will not participate in adjustment. Then I need to readjust my block while using current solution. Okay. In filter of points displaying, specify visualization of projection centers residuals in ground XY. As you see, it seems that residuals directions are close to the same direction in each strip. It's possible that there is a systematic error in position of projection centers in each strip. Let's come back to adjustment parameters and open systematic error compensation button. Let's activate command for strip options, press OK. Then activate a mixed self-calibration of camera for all parameters. It's needed to make inter-orientation parameters of non-calibrated camera more accurate. Self-calibration is applied just with a bundle adjustment when the project is provided by enough number of accurate ground control points. Okay, and now adjust the block again. Okay. In brief, residuals report mean information about errors of each type. If each type of points is shown values with splat symbols, indicate that they are measured or acceptable residuals. Value of sigma parameters shows how much adjustment errors correspond to a priori accuracy of points coordinate measurements. If a priori values of accuracy are specified right, sigma values will be close to 1, between 0.7 and 1.4. If sigma exceeds value 1 significantly, it indicates the errors in points coordinate measurements and shows that acceptable residuals of GCPs and projection centers are overestimated. If sigma is significantly less than 1 value, it demonstrates that acceptable residuals of GCPs and projection centers are underestimated. If to increase values of accuracy for exterior orientation data, it's possible to achieve better values of adjustment accuracy. After adjustment is complete, press Save button. Return to camera management and please reassign a new self-calibrated camera to roll images. I select all images from the list in the left column and execute reassignment of new camera, self-calibrated camera. As we see, coordinates of principal point, focal lengths and distortion coefficients have been changed after performing self-calibration of camera. Okay, please synchronize the project. Okay, let's return to the block adjustment toolbar and try to readjust our block with new parameters of exterior orientation. Okay, then let's display type points, our acceptable residuals, in our case just projection centers are our acceptable residuals. Then display just ground control points. And let's specify state for some of them as check. Checkpoints is recommended to select in central part of the block. Readjust. A report on ground control and checkpoints shows that their measurements meet acceptable residuals. If needed, I may open full report. I may save it, I may print it if needed. And if necessary, when you can't achieve a suitable result of adjustment, we recommend to remeasure type points once again with new acceptable residuals and new camera with additional self-calibration and perform next iteration of block adjustment. And then don't forget to save adjustment results. The subsequent processing of adjusted block, I mean DTM creation, auto rectification, stereo vectorization, is performed in a way similar to processing of aerial and Pashburn scanner project.